Hi everyone, this is Yi. I'm going to share with you the topic, how does climate change affect the opening of the Northwest Passage through Canada Arctic? To figure out the question, three key points should be kept in mind throughout the presentation: the sea ice decline, navigation change, and lastly the challenge it has. More than a century ago, using the Northwest Passage through the Canadian Arctic Archipelago for cargo transportation at the route from the Pacific Ocean to the Atlantic was impossible. This is because sea ice covered most of the Atlantic Ocean at the time, and even in summer, the route was mostly blocked by impenetrable ice. Explorer has been testing the icy water of the Arctic in search of a sea route through the Iceland of mainland Canada. The Arctic Ocean is usually considered the Arctic Mediterranean Sea. It communicates with the North Atlantic through Fram Strait. Fram Strait is the only deep passage and the only one allowing for two-way exchange. The narrow channel of the Canadian Arctic Archipelago are dominated by outflow from the Arctic Ocean. Through the shallow and narrow Bering Strait, the Arctic Ocean is connected to the Pacific Ocean, which allows for an inflow of warm Pacific water and a communication between the North Atlantic and the North Pacific. The Arctic Ocean is an enclosed ocean. There is discovery of the stratification of salinity in the Arctic Ocean, and the stability of the upper part is strong enough to reduce mixing with the water below, allowing the upper low salinity layer to cool to freezing temperatures. The warm North Atlantic water flows into the Arctic Ocean through the Fram Strait. The heat carried by the Gulf Stream is not sufficient to melt the great amount of sea ice in the Arctic Ocean, because the runoff from Siberian River is large enough to keep the heat away from the surface, allowing sea ice to form and grow in the Arctic Ocean. Change in temperature of the Arctic Ocean affects the growth of ice sheet in winter and melting rate in summer. According to the Haro reports, Arctic sea ice cover was still expanding in the early 20th century. However, increased heat and moisture transport to the Arctic due to global warming, triggering feedbacks in the Arctic climate system. One of the feedbacks that amplify the warming in the Arctic is the result of summer sea ice extent reduction, which increase the air temperature in late fall and early winter. In addition, Park in their 2015 report mentioned that an increase of the water vapor content in the surface atmospheric layer, accompanied by increased downward long-wave radiation, is caused by tropospheric water and heat from mid-latitudes. Therefore, when heat accumulates in ice-free water is released into the atmosphere, the surface air temperature in the Arctic exceeds up to 75% more than the background volume. The enhanced inflow of warm Arctic water. The enhanced inflow of warm Atlantic water is also found to reduce sea ice thickness via sea ice melting from bottom surface. As the figure shows, the annual Arctic sea ice minimum area has a significant negative trend from 1979 to 2020. There are models that the ice will disappear by the mid-2030s if we keep the current rate of warming of air temperature. Now back to the question, how does climate change affect the opening of the Northwest Passage through Canada Arctic As we know, the Arctic has warmed rapidly, with rising temperatures and reducing sea ice have driven reef change across the Arctic, and opening a pathway for shipping routes. Over the past few decades, warming water in the Atlantic Ocean have increasingly contributed to the melting of sea ice in the eastern Arctic. Sea ice extent in the Canadian Arctic has decreased by 5 to 20% per decade in summer, with a significant reduction in the proportion of multi-year ice. The Northwest Passage is currently navigable for a short period late in most summers. Mondre and her team 2021 used model to predict change in sea ice under 1, 2, and 4 degrees of global warming. The Beaufort Sea represents the western edge of the axis of the Northwest Passage. Through 2-degree warming, all shipping types indicate a 100% navigation probability for part of the year. Furthermore, compared to 2 degrees and 4 degrees Celsius of global warming, resupply ships would be available almost year-round in southern Newfoundland. Under 1 degree of global warming, the greatest increase in navigability occurred during the summer months in most Canadian Arctic communities. However, the ice arches and bridges have historically blocked the flow of the Arctic Ocean multi-year ice southward into the Canadian Arctic for most of the year have weakened, resulting in increased southward ice abduction into major shipping routes. As a result, there are many regions where thick multi-year ice tend to accumulate within the Northwest Passage channel of the Canadian Arctic archipelago. Climate models predict that even as sea ice disappears from the Arctic Ocean, the northern part of the Canadian Arctic archipelago will remain a stronghold for multi-year ice. In fact, the minimum sea ice cover in the Canadian Arctic archipelago shrank by 6.6% and the multi-year ice by 8.6% each decade between 1979 and 2021. So the amount of sea ice in the region is indeed decreasing. It's not in the right way for the Northwest Passage to become a viable alternative. In conclusion, the Arctic is changing faster than any other region on Earth, and this change can have profound effects on Canadian Arctic shipping activity, infrastructure development, and function and structure of the Arctic ecosystem. Climate change is causing most of the sea ice in the Arctic Ocean to melt away, and eventually, the Arctic Ocean become an ice-free zone as temperature continues to rise. The reduction of sea ice have facilitated increased shipping traffic volume across the Arctic. However, the high latitude of the Canadian Arctic archipelago and the northern route of the Northwest Passage present challenge due to multi-year ice. Therefore, considerable uncertainty remains as future shipping activity in the Canadian Arctic is heavily influenced by rising global temperatures. Thank you.